Hey everyone, hope you guys are having a enjoyable break. We're going to get ready to do some physics finally. So here's going to be one of your first lessons. We're going to start learning about how things move and behave. And the first thing we're going to look at is something called speed. Speed is all about how fast something is moving. And there's a way to figure that out and calculate that. We're going to do a couple lessons today. And by the time we're done, you should have a good idea about how to do that. Although I'm still learning how to use this iPad stuff, and it's going to be pretty janky in the beginnings, but just bear with me. All right, so let's get started with speed. Last year, me and some students did a foot race. You'll see me racing Andy Driscoll. It's clear who's the winner. Andy beat me. But the question is, how fast were we actually running? And that's what we're going to figure out today, how to calculate speed. In order to calculate speed, which is how fast you travel from one point to another, you need the distance that you're traveling, the distance, say, between point A, the basketball hoop, and point B, the holly bush, and time, how long it takes me to do that. So I'm going to run from here over to the holly bush, and you'll be able to see exactly how long it takes me to do that, since we'll have a timer. And here I am running, and I'm running, and there I am. All right, so you saw me run from the basketball hoop to the holly bush. And we're going to take a look here on our screen here. And you guys are aware that I ran from the basketball hoop to the holly bush, and based on the timer as I ran across, I was running across that there, it took me approximately, I'll write down the time. Oh dear, it's too fat. It took me approximately, my time was about 5 seconds. Now let's pretend I actually measured the distance. I didn't actually. But the distance between points A and B, the distance here, we're going to say was 10 meters. A little over 30 feet. Okay, so that was my distance. That's how far I traveled. And here is my time, 5 seconds. I ran 10 meters in 5 seconds. There's a way to calculate how fast I'm actually running, and it's actually quite simple. And I want to tell you a little bit about that. But before I do so, I want to talk a little bit about some Greek letters. We're going to look at a Greek letter here today, and it's called delta. And the Greek letter delta actually looks kind of like a triangle. Typically one side tends to be a little bit thicker than the other, but there it is, delta. And the letter delta in science refers to the term change. So whenever you see delta anything, it means something is changing. So when I look at my distance, you can see that my distance went from point A to point B. And this change from here, as I run across, my distance is changing. It's getting longer. So we can actually refer to this as delta D, change in distance. Sometimes they refer to it as delta x. And this means change in position. My change in my position. Okay. Delta t would simply mean change in time. And we saw the time elapse. It was 5 seconds long. So my delta x, my change in my position from points A to B, and my delta t, my change in my time, which was my 5 seconds. Now the equation here is the distance I traveled and the time in which I traveled it. And this is actually written in a particular way. It's written as distance over time, or change in position over time. It's a division problem. So it looks like this. Delta, meaning change in my position, divided by delta, meaning change in my time. The change in my position divided by my time. Now, that might look new to you, but honestly, you can see that the meters is right here, 10 meters, and my time is 5 seconds. So here's my meters right here, and you can see my seconds right here, 5 seconds, and we'll just put it all together. The 10 meters will be included here, and the seconds will be included here. We just rewrite it. So I rewrite this as 10 meters over 5 seconds. You can see it comes right from my problem. And then you can do the math. 10 divided by 5. Well, 10 divided by 5 works out to be 2. 2. But the meters and the seconds are totally different units. They don't cancel, so we keep them both, and we say it was 2 meters per second. And this is how fast I was moving. We'll go over this again a couple more times, and we'll explain how this works. All right, we're back. We're going to work on this a little bit more. You remember I was showing you just a little while ago how I was running from my basketball hoop, which I called point A, to my holly bush, which I called that point B. It's a bit of a sad bush. My tree fell on top of it last year, so it's not looking so great. Anyway, we said the distance traveled there was 10 meters. And so my position from point A to point B has changed. And we say that we're using this delta symbol to represent that change. My change in position is delta x. Sometimes it's delta d. My time also changed. It took me 5 seconds to run that. So my time is referred to as delta t, the change in my time. To calculate how fast I'm running, it's a ratio, it's a relationship between the distance you're traveling and how long it takes you. If you travel a great long distance in a very short period of time, you're going very quickly. But if you go a very small distance in a very long period of time, you're going very, very slowly. And we do this equation, it's division. Basically, it's the delta x, the change in my position, divided by the delta t, the change in my time. And we did this a little bit, and we saw that it was 10 meters divided by 5 seconds, which gave me 2 meters per second. Now, let's look at this again with a problem. So before we get to the problem, let's just look at speed itself. Speed, as we say, is the distance traveled by an object in a unit of time. It's how far you go in a certain period of time. And to kind of refresh ourselves, we know delta x is change in position, delta t is change in time, and this gives us another variable which we call v, which is speed. V oftentimes refers to velocity. Sometimes you'll see v with a line over it. There's lots of different things, but we won't get confused by that. Let's try a problem here and see how we go about doing this. So let's go down to our first problem. If a car travels 400 meters in 20 seconds, how fast is it going? Okay, welcome to your first physics problem. Whenever you're doing a physics problem, the first thing you want to ask yourself is, what are they asking me? What does it want? Okay, what is the question asking me? Well, it seems to be asking me, how fast is it going? Okay, how fast is it going? Well, this is important. How fast? Well, I know the variable for fast is, it's talking speed, isn't it? Okay, so it's talking speed. We want v. That's what we're looking for. Okay, v. The next thing I always want to do is I want to write, once I know what it's looking for, I want to write down the equation for what I need. Okay, the equation for this, for speed, we already talked about it. It's delta x over, let's just make my colors the same, delta t. Distance, or change in position, divided by my time. All right, so let's go back to the equation. Do we see a change in position? And sure we do. We see distance right here. Right? Here's my position, 400 meters. Okay, that's my delta x, right? Or my delta d. And do I see time? Sure I do. Here it is, 20 seconds. Right? That's my delta t. The equation's giving me everything I need. This problem tells me everything I need. How long I've been traveling for, how far it travels. Now we simply put those things in. 400 meters replaces the delta x. So I put 400 meters in. Time, instead of delta t, I'm going to do 20 seconds. Right? Now we simply just do the math. What's 400, right, divided by 20? I'll give you guys a few seconds to work that out. All right, you guys do the math? I hope so. So, you take 400 meters divided by 20. 400 divided by 20 works out to be 20. But the meters and the seconds can't cancel out, so it works out to be 20 meters per second. All right, let's do another problem. We're going to do it a little bit quicker. Same format, though. We're going to do this exact same way, but follow along if you can. Okay, here, we're going to move 50 meters in 10 seconds. What is your speed? Again, what are they asking for? What do they want from you? In this case, what is your speed? It's spelling it out pretty clearly. It wants your speed. Speed is v. So, the next thing I'm going to do, write down the equation. Delta x over delta t. That's the equation. That's how you find speed. The change in your position divided by time. All right, now we go back into the problem. Let's look for a change in time. Delta t. Where's delta t? I see delta t right here, 10 seconds. That's how long my time was. Delta t. Well, what's my delta x, my change in position? My change in position is right here at 50 meters. I moved 50 meters. That's my delta x. So what are we going to do? We're going to put this information into the equation. The 50 meters goes here. The 10 seconds goes here. So let's start with the 50 meters. Delta x is 50 meters divided by delta t, which is 10 seconds. Well, what's 50 divided by 10? 50 divided by 10. I'll give you guys a couple seconds to think about it. Is 5 meters per second. Now, some of you might be on this, you get it. Others of you might be a little bit confused. Don't sweat it. We're going to spend a week on speed, so you'll have plenty of time to figure this stuff out. So if you're confused after this, like, I don't know, 12, 13-minute video, I apologize. We will get you sorted out by the end of the week, I promise. Hey guys, well, I know that was probably a lot, whether you're a raptor or a cougar or a grizzly. The math, trust me on this, the math isn't hard. It's just a matter of figuring out, what do I do with these numbers, right? What am I supposed to do with these things, like distance and time and delta? What is all this? By the end of the week, we will have you there. I'm not going to go any further. We're just going to stick with speed for now, because my video already is like 15 minutes long, and I'm sorry. I'm going to give a little tiny assignment, just a few word problems. Just give it your best shot. See how they work out, right? We're going to do some more practice with them. I don't even know where I'm supposed to look with this thing. And then once we're done with those practices, we'll go over the problems and we'll figure it out. So don't beat yourself up. We are going to work our way through this, and you're going to be awesome. You're going to be awesome at calculating speed. I guarantee it. All right. Well, there's a little tiny worksheet. I'm going to post it. Give it a try. It's okay if you get them wrong. Just do your very best. And then we'll see you tomorrow.